In this video, we'll talk about what injective and surjective functions are. So let's get right into a definition. A function f from s to t, so that means s is the domain, t is the codomain. We say that it is one-to-one or injective if for all a and b that are in s, so that means those are inputs in the domain, such that a is not equal to b, that means they are different inputs, then f of a is not equal to f of b. So that means their outputs have to be different. So this is saying anytime I have two different inputs not equal to each other, then their outputs are not equal. Their outputs are different. So let's draw a diagram to get a visual sense of what this means. Let me draw an oval for my domain, S, and an oval for the codomain T. And maybe in the domain there are three elements, and maybe in the codomain there's four. I'm also going to draw a diagram of something that's not injective, so let me just copy these set of dots here. Okay, and for something that's injective, all these inputs have to get mapped to different outputs. So maybe this second one gets mapped to this one, and maybe the third one gets mapped to that one. So there are no two inputs that have the same output. That would be injective. So something that's not injective might be, well, maybe this first thing gets mapped to this, and maybe the second one also gets mapped to the same thing. And then no matter what the third one gets mapped to, the fact that there are multiple inputs with the same output makes it not injective. Okay, so there's an equivalent way to say this using the contrapositive, because I have an if-then statement. So the contrapositive would say, well, if the conclusion is false, which would mean if f of a actually equals f of b, so in other words, if the two outputs are equal, then the if part is false. So that would be saying then, well, a has to be equal to b. So this is saying if two outputs are indeed equal, well, then their inputs need to be equal for it to be an injective thing. So this contrapositive way is really commonly used when we prove things are injective, and we'll do that in a future video. Okay, so we are ready to talk about surjective. So we say that a function is onto or surjective if for all lowercase t in capital T, so that means this lowercase t is in this codomain, so it's a possible output. And it's saying for all of these elements in the codomain, there needs to exist an element lowercase s and capital S, so it's something that's in the domain, such that when I plug s in as an input to my function, I'll get t out as an output. So I need to be able to do this for all of the values in the codomain. So let's draw a diagram for this. So I will draw an oval for s and an oval for t. So maybe this time s has 4 dots, and maybe this time t has 3. I'm also going to draw something that's not surjective, so I'll copy this. So something that is surjective, all of these things in the codomain have to be actually achieved as an output. So maybe this one goes to the first one, and maybe this one goes to the second, and maybe this one also goes to the second. That's okay. And maybe this one goes to the last one. So the fact that every single thing in the codomain gets landed on, I'm going to fill in the blank, gets landed on or mapped to by something in the domain means it is surjective, or another word for that is onto. Something is not surjective if, well, there's something in the codomain that doesn't get landed on. So I'll draw an example. Well, what if I had this going to the first one, and that also, and this also, and maybe the last one then goes to this bottom one? Well, there's something in the codomain that doesn't get landed on. This thing right here. This didn't get landed on. So that means this is not surjective. It is not onto. So an equivalent way to state this definition is, remember the range, we saw this in the last video. The range is all of the outputs I actually get. And in this first picture, well, we got all of the outputs in the entire codomain. So that would be saying the range actually is equal to the whole codomain. In this not surjective picture, well, the range would only consist of this element and that element down there, because those are the only ones that got landed on. But it would miss this one right here. So it wouldn't be the whole codomain. I can also say this using my notation for image. Remember, S of S means the image of S. That's if I plug all the values in my domain into my function, what are all of their outputs? Well, if it's surjective, their outputs have to be the whole T, the whole codomain. Okay, so let's do an example now, which asks, are the following functions from R to R injective and are they surjective? So let's draw some axes. So in part B, we'll have the arctan function. And then in part C, we have this cubic function. So I want to think about all of these graphs. So the domain is the reals, the codomain is also the reals. So I know with 3x plus 2, this graph is a line with slope 3 and the y-intercept is at 2. And to test if it's injective, what I need is, if I take any two inputs that are different, maybe I'll call one A and another input B, their outputs need to be different. Well, the output is whatever the y value is on the graph. So this point is A comma f of A, and that second point is B comma f of B. And I think it's not hard to tell by looking at the graph that, well, these y values are definitely going to be different as long as I pick these inputs to be different. Graphically, so as a result of this, this first function is injective. It is injective. The graphical way to test for this is an injective function passes the horizontal line test. Because if instead the graph had kind of curved upwards like this, well, then I could draw horizontal lines that cross the graph more than once. Like this would cross it here and here. So there would be multiple inputs with the same output, and that would be bad. Okay, so an injective function is going to pass the horizontal line test. Is this surjective? Meaning, will all of the things in the codomain, all the reals, actually get landed on? Well, that's asking, well, if I take any y value along the way, is there always a point on the graph that reaches that y value? But yeah, I can tell, yeah, this one is here, for that next y value is there, for this next one it's here, for the next one it's there, for that one it's here. No matter which y value I pick, I can always do that. So this is surjective. Okay, nice. All right, so part B, we got arctan of x, which is another way to write tangent inverse of x. So thinking back to trig class here, the graph of arctan of x goes through the origin, and then it has a horizontal asymptote at pi over 2, going that way. And then it has another horizontal asymptote going this way at negative pi over 2. So we'll draw in those asymptotes with the dashed lines. So will this pass the horizontal line test? Yeah, any horizontal line that I draw will never cross the graph more than one time. So we don't have any problem points where I have multiple inputs with the same output. It is injective. Is it surjective? Like, will all of the things in the codomain, all the reals get landed on? Well, no. There's many things like pi up here that never gets landed on. Pi doesn't get landed on. We never get that output. Okay, so it is not surjective. I'm just going to abbreviate not surge for not surjective. Okay, one more graph here, x cubed minus x. To get this graph, I could factor the function. So I can factor out an x and be left with x squared minus 1. Now we see a difference of squares, which factors. So this is x times x minus 1 times x plus 1. And now if I set this whole thing equal to 0, I can get my x-intercepts. So the x-intercepts are at negative 1, 0, and at positive 1. We have x-intercepts at all of those. So I'm going to draw those points. If we were to plug in some other values in for x, like in between these and to the sides of them, we could eventually get the shape of the graph, which looks like, kind of goes up like this, then it goes down, and now it's kind of symmetric here on the other side it'll turn out. So it looks like this. So this graph, does it pass the horizontal line test? Well, no. For example, if I draw a horizontal line here at the origin, it crosses it more than one time. So this is not injective. I'll write not INJ, not injective. As a specific counterexample to why it's not injective, notice, for example, that like f of 0 and f of 1 those are equal to each other. These two outputs are the same, even though the inputs are different. Is it surjective? Is every real number in the codomain landed on? Yeah, no matter which real number I pick, it's always landed on. If I pick one here, it's actually landed on in multiple spots. Okay, so because that's true for any real number, any y value that's real, this thing is surjective. It is, let me put it in pick. This thing is surjective. And there we have it.